Good morning, class, or good afternoon, or whatever time it is that you are watching this. Today we are working on Module 4, Lesson number 12. Um, so we'll get started. First, you need to do the opening exercise. So if you haven't already done that, please pause now and complete those first two problems. Great. So if you have done that, that's fantastic because that's just kind of a good way to warm up your brain. I know you already know how to do those two things. Multiplying 2 times 5, I know, is something you've already got, right? This is mostly just reminding yourself about what we're working on. So let's go ahead and get started right with example number 1. So number 1, we are working to solve, write an expression that is equivalent to 2a plus b. But they give us a few steps to do before we come up with that expression. So first we need to create a model to represent a plus b. So we've got the a plus b part that we're working on right now. In the end, we're going to have something that's equivalent to 2a plus b. So a plus b, we can represent that super easily, right? We draw an A, and we draw a B, and we say that all together, this is A plus B. Okay, that was not that hard, right? That's stuff we've done before. But now it says the expression 2a plus b tells us that we have 2 of the a plus b. So we need to create a model that shows 2 groups of a plus b. So all that's going to be is I'm going to basically double that model. So I'm going to do my a and b. Right? And then I'm going to do it again. A and b. Just like that. That's 2a plus b. We've got 2 groups that are a plus b. So how many a's and how many b's are in the diagram? Well, I see 2 a's and I see 2 b's. So what could we do? Well, it says how would the model look if we grouped together the a's and b's and then grouped together the a's and then grouped together the b's. So we would suddenly have our a's next to each other and our b's next to each other, right? And now we could say, well, this is 2a and this is 2b. What expression could we write to represent this new diagram? Well, I could just write 2a plus 2b, right? That would represent this new diagram. Wait a second. This expression's written in expanded form. That's the expanded form. What? What we can conclude here, suddenly, is that 2a plus b equals 2a plus 2b. Wow. We just discovered something pretty cool with math. All right, so now we need to make sure we can prove that these 2 forms are equivalent. So I'm going to come back over here and erase my models. And while I do that, we're going to try, if we let a equals 3, actually I'm going to use red to prove. I think red is a good proving color. So a equals 3 and b equals 4. Let's make sure these are equivalent. So first we'll take the 2a plus 2b on one side. And then on the other side, we'll try, maybe I'll do black with the other equation. The other equation was 2a plus 2b. right? So we need to make sure these are equivalent. So if I put in 3 here for 2 times 3 plus 4, and then on the other side, well, here, we'll work with just this side first, and then we'll try the other side. So 2 times 3 plus 4. So first we need to do 3 plus 4, which I know is 7, 2 times 7. And then I need to multiply 2 times 7 is 14. Great. Now, let's try on this side, replacing A and B. So you get 2 times 3 plus 2 times 4. And when I do this, suddenly I can multiply these out. So 2 times 3 is 6, plus 2 times 4 is 8. So now we have 6 plus 8, which is 14. So wait, they were in fact equivalent. We just kind of helped prove that these are equivalent. And if you don't believe that these are equal still, you can keep substituting A and B with other numbers, and hopefully, in fact, certainly, you will end up with the same result on both equations as long as A and B are equal in both. That's awesome. So now we get this question, what happens when we double A plus B? When we double that, A plus B, we're doubling A and we're doubling B. That's what our answer would be, is that we get to double both variables. That was a great example. I love examples like that because we get to start discovering new things. And man, can you imagine being that mathematician who discovered this for the first time? I can't even imagine. That would be so cool. But let's keep going. Let's go on to example number 2. Write an expression that is equivalent to double 3x plus 4y. So I'm going to start with my red this time. So we want double 3x plus 4y. So how can we rewrite double 3x plus 4y? Well, I know double is the same as multiplying by 2. So I could write 2 times 3x plus 4y, just like that. But wait, we just realized that, we can multiply this and then this and kind of simplify it, right? So really, we can write that as 6x plus 8y. I got the 6 by multiplying 2 times 3. I got the 8 by multiplying 2 times 4. So there we go. That's different ways we can write it. Is this expression in factored form, expanded form, or neither? So this first one here is in factored form. I'm just going to write the factored. Did not leave. We've got space on the other side. Let's write it over here. This is factored form. There we go. Factored form. And the second one is expanded form. So this is factored form, this is expanded form. Okay, so let's start this problem the same way that we started the first example. So what should we do? Well, if we want to do the same way we started the last one, we want to start out by creating a model. So I'm going to make a model of 3x plus 4y. Like that. Now we're going to change to show 2 times 3x plus 4y. So really all I have to do is have 3 of those, or 2 of those. So 3x, 4y, that's 3x plus 4y, and then 3x, 4y, that's 3x plus 4y, just like that. I'm just making 2 copies of that first model. So now, are there any terms that we can combine in this example? Yep. Let's try combining all those x's and all those y's. So you end up with 3x and a 3x. Now I could write that as 3x plus 3x, but I think I'm going to write it the more simple way, which is 6x, right? And then 4y, that's 8y together. So that's how we can combine this. There's 6 x's and 8 y's. So that's what this model is showing is 6x plus 8y. What is an equivalent expression that we can use to represent 2 times 3x plus 4y? So what's equivalent to 2 times 3x plus 4y? Would be 6x plus 8y. And we just proved that with our models. It is the same as saying something like 2 times 3x plus 2 times 4y. So how would we solve this question without a model? When there is a number outside the parentheses, like this, I would multiply all the terms on the inside by the parentheses. So I would multiply 2 times 3x, and I would multiply 2 times 4x. Without a model, you can still do this, which is pretty fantastic if you ask me. Okay, we've got another example. Example number 3. This one should be hopefully short. It looks short on the page at least. Let's see. Example 3. Write an expression in expanded form that is equivalent to the model shown below. Well, let me draw out that model for you so we can see. Oh, my marker's dying. This is the last good marker from the classroom, too. Right, well, that's life. All right, so we've got 4x plus 5 multiplied by y. All right, so an expression in expanded form that's equivalent to this model. I could write this. Well, we're doing some multiplication. I see we're going to multiply y times 4x. I'm going to multiply y and 5. So I'm going to actually put these first because we always go in alphabetical order. We always put the number before we put the letters. So it's going to be 4xy plus 5y. That's going to be our expanded form here. Now, we can make this a factored expression, and that would be simply putting, since we're multiplying by y on both sides here, on both part of the addition, we're going to say, okay, that's the greatest common factor. So that greatest common factor is the number that goes on the outside of that parentheses, and then we say 4x plus 5 goes on the inside. So y times 4x plus y. How can we rewrite this expression in expanded form? Well, I just did that for you. We would rewrite it, really, if we came up with this part first, we would say, okay, y times 4x plus y times 5, and then we would figure out that that ends up being really 4xy plus 5y. That's how we rewrite it without using a model to solve it. Yes, there was a model in the first question, but you guys see the point, I hope. In fact, let's go ahead and work on example 4. This is our last example. And we're going to use all the work in our previous examples to write this expression. So what is an expression in expanded form that is equivalent to 3 times 7d plus 4e? We want something that's equivalent to this. Well, first, we will multiply 3 times 7d and 3 times 4e. So I end up doing 3 times 7d plus 3 times 4e. Okay, 3 times 7d is 21d. All right, 3 times 7 is 21, so 3 times 7d is 21d. All right, and then 3 times 4 I know is 12, so 3 times 4e is 12e. We've got a couple different ways to write this, but in the end, what we've learned is 3 times 7d plus 4e equals 21d plus 12e. I'm going to box that off so you can see exactly what our answer is. And there we go. So we've got our work, and then our answer. We make our answer super clear, and then we get to move on from there. All right, at this point, I've done all of the examples. What you have left are the exercises. You do not have to do the problem set today. I think because the exercises is already 8 problems, that's quite a bit, especially to do on your own. It does ask you to use a model for the first 2. So hopefully you were paying attention to the first couple examples. If you didn't, or if you need to look back, that's a beauty of a video instead of having me in person, is you can just rewatch part of the lesson. Then, of course, 3 through 8 is just using the distributive property to write equivalent expressions in expanded forms. So it's kind of like what I just did for that last example is what you're going to be doing for 3 through 8. So 1 and 2 are very much like my first couple examples, and then my last example is what 3 through 8 should end up looking like. If you have any questions, or you would like to work on some problems with me, please let me know. I'm here all day, every day, until, May 4th? So let me know. I'm here for you, okay? I'll talk to you guys soon.